everyone is here. I'm going to go ahead and get started. What's interesting about this session is I'm not sure what my audience's needs are. So I'd like to adjust as we go. And if you want to chime in at any time, hopefully I can make sure that we're talking about what it is that you need to hear. So let me introduce myself. My name is Heather Delity. I'm a middle school STEM teacher. I do robotics and esports at Gouverneur Middle School, and I'm in the North Country. So if you are familiar with where Watertown is, you just keep going north and you keep going north. And when you eventually, get up to where I am, it's a great place to live, small town, very rural. But it's been a great experience for me. I love being here. I love how New York has such a diverse population of urban and rural and suburban, and we just cover the gauntlet of all the different things that we can be. So love it. Oh, great. Looking to start robotics and or esports. That's wonderful. So what I wanted to talk about today was what do I need to think about, and what are some ideas for adding some computer science and STEM into my curriculum. So what we want to try and accomplish today is figure out what are our goals for adding those things to my curriculum. What learning objectives that I currently have can I achieve with some computer science and some STEM projects that maybe don't take away from what I'm already doing? And what are some examples of technology that I can use to design projects that'll meet my objectives? There are basically two different kinds of situations that this presentation is going to address. So the first one is people who are teaching in another content area. You are not a dedicated STEM teacher. You are teaching some content area, and you have been challenged to incorporate some of the computer science standards into your area, right? Find a way to hit some of these standards. And so that's kind of an awesome thing we're going to address. If that is your situation, we're going to talk about that a little bit. And then there's also people who are going to teach a computer science class. Like you are going to, whether you have done it before, maybe you never have, maybe that's not even your area, but you've been thrown into, I'm going to have to teach a computer science class and I don't know what I'm going to do. So I'm hoping that I can address both of those things with this slide deck, and really your questions and comments will, I will fix the bit.ly if it's asking for access. I thought I set it so that everyone with the link would have access. So I'll double check that. I will fix it at the end of this session. So just hang on to that and I'll make sure that it works by the end of the session. So I'm a middle school teacher. I see Mellon said the same thing, middle school, but I'm teaching an advanced, just a computer coding class to my 8th graders that could plug into a high school very easily. Because it is a little bit more advanced, but a lot of what we're going to cover could apply to elementary up through high school, depending on how you want to apply it. So let me jump on here. First, you have to really think about what your goals are. So if I'm going to incorporate some STEM and computer science into my curriculum, is my goal just exposure? I want my students to get exposed to some of those computer science and digital fluency standards in what I'm already teaching. Or do I want to do skill building? Do I really want students to learn and apply some of those computer science principles? And we're going to actually be digging into some coding and some other things. Do I want to keep it theoretical, where I'm going to do a lot of unplugged activities and one-off kind of things to hit these standards and focus on a lot of the theory behind things? Or am I going to dig in and do some actual coding? Am I going to have my students get on that technology and be doing things with it? All of those are valid options for the standards to be able to hit them, depending on who you are and what you're trying to do. So you want to think about that first and decide what is your goal for this course. Are you just adding some things in, keeping it less technical, but still accomplishing some of the key important details of the standards? After you've thought through that, and you've kind of decided what your goal is, then we divide into those two groups. Am I rolling this these projects into a non-computer science content area, right? So I'm a elementary school teacher and I don't have a dedicated computer science class, but I'm going to roll some of these things in. Or am I teaching a actual computer science course and I need to hit as many of those standards as I can, and I've got to be able to do it that way. So depending on which one of those people you are, you've got two different sort of problems to tackle. So hopefully this will help with that. So everybody, I think, has gotten familiar with the computer science and digital fluency standards. We've been talking about them for a while. If you've been to the CSDA conference where the New York teams were meeting up, if you've been to any professional development for these standards so far, you've hopefully been exposed to them. And we've got the 5 key concept areas: impacts of computing, computational thinking, networks and system design, cybersecurity, and digital literacy. There are courses that are already kind of designed for you that you can pull from that try and hit all of these standards. You may be focusing on just a few of these key concept areas. That's okay. You want to think about what key concept areas you're going to target. Are you going to try and do something for all of them, or are you just going to focus on the impacts of computing in society? If you're a social studies teacher, that may tie in really well with your content area. If you're teaching a dedicated computer science class, you may focus more on computational thinking and do some actual algorithms and codings, but hopefully you can also hit on these other content areas because we want to make sure that they're all getting exposure. They're all important. Sometimes the network and system designs can seem intimidating. It seems like I need to be an IT person to be able to teach that class. Cybersecurity can sometimes be intimidating if we feel like this is not an area I'm really on top of. There are great resources that help us hit all those areas without being an actual IT professional. So don't be intimidated by them and feel like you can't do them. And if you are a dedicated computer science teacher and this is old hat for you, then that's great. You can find ways to incorporate some of the things like digital literacy that maybe in just a hardcore coding class, you're not hitting all of the aspects of digital fluency that we want to hit because we're just focused on coding. So the challenge really is to try and tie as much of this as we can, but know that it's okay if you just focus on one area. So which one of these people are you? Are you incorporating CS into another content area and you want to stay unplugged? Let's just keep this comfortable, and I don't have a lot of technology that I'm going to pull in. This is really not my area, but I can still tie in some of these standards. Or do you want to incorporate CS into another content area, but you are ready to go with using some of software that's out there to do some really incredible things? Or are you creating a brand new computer science course? I've linked at the bottom of the slide the Smart Start grant program. We talked about this a little yesterday if you were in some of those sessions. There are resources that different districts and groups all over the state who worked with the Smart Start grant created resources that are now out there and shared with us on the New York Education website. So you can click on that link and you can see tons of resources. And for the purposes of this presentation, I can't highlight all of them. There's just not time, and they're all out there for you. So I'm going to touch on a few things and talk about my experience a little, but throw in as much available resource for you that will help you decide what you're going to use and what you're going to do. But this Smart Start grant is really a beautiful thing, and I think I was involved in one group that did it, and we really came up with some great work. It was a group of teachers from our county. Actually, I think it was the whole North Country area, so 3 or 4 counties. And I know all over the state we've worked on this, so great resources for you there. So let's say you are one of those people who's incorporating computer science in, but you want to stay unplugged. Again, there are millions of resources for you. I'm going to just highlight a couple to give you a few ideas to just kind of get your mind going. So create a game was a fun activity that we found in our digging and looking, and a lot of us were talking about. And you can adapt it to almost anything. So it is a project where you have your students create a board game, and they design it to, on whatever poster board, cardboard, whatever you want to have them created on. A lot of kids love those card games where I'm, showing my ignorance here, but those, where it's a total card game, Pokemon, or one of those other ones where they're trading cards and cards have value and they're battling using the cards, or a traditional board game, your Monopoly kind of thing, but you create a board game, and videos are provided at the link here that teach concepts like abstraction, decomposition, pattern recognition, algorithms, all that computational thinking stuff that's so good. You're going to hit with all of this in this one project where you actually aren't using devices. They are doing this in the physical world and designing this game. And because the board game itself, the content of that can be whatever you want. You can use it to have a Civil War theme, or something in ELA class, or something in math class, where the game is about whatever it is that you want your students to make the game about. And they decide how you proceed in the game, how you advance, how you beat the opponent, how you win. And they're using all these computational thinking techniques to design it. And I think, let's see if I'm sharing my screen. I think I need to, I'm going to switch how I'm sharing. So give me just a second. So, whoops, when I share, you can actually see it. And now I'm not sure how to do it. I apologize. Give me just a second. Oh, how did I share that a minute ago? Nope. Nope. Oh, I've lost my ability to share my screen. Oh gosh, I'm so sorry, guys. Give me 1 second to remember how this went. If anyone wants to chime in and remind me how to share my screen, that would be great, because it's not that one. And you know how when you have people watching you, you get nervous and then you can't remember everything? Yeah, it's that is what's happening right now. Maybe I need to refresh. Okay, I'm back, but I still can't share my screen. Oh my gosh, I am so apologetic, guys. What is the problem? Yeah, let's see if I can share this with one of you. Got it. Oh, I'm so sorry. All right. Here we are back to the slides. Okay. So that was terrible. I apologize. Thank you all for your patience. You're very kind. I wanted to show you this game link. So our interactive board game, this is just one example. You obviously could take this and do whatever you want to do with it, but it does have a great activity guide. It's got the videos. It's got all kinds of wonderful information for you if you wanted to do this activity, and there's the link for that. And this is something that you could adapt and make it take as long as you want or as short as you want, and you're hitting all those computer science standards. All right. If you want to incorporate computer science into your content area and use some technology, my favorite way is as a choice for assessments. So if I'm teaching a class on anything and I'm going to have students do a presentation or do a video or take a test or create a slide deck, right? They're going to do one of those things at the end as the culminating assessment. Another option for them is to create a program. It can be a little animated program that does the presentation for them. And it's just a different way to present the information as evidence of their learning. And Scratch is obviously a great way to do it. It's a free tool. If you have ed law issues with that and privacy, there are many, many other tools that you might have access to that you can use for that. We've used Scratch with anonymous accounts. And so there's ways for you to do that. The really nice thing is that you as the teacher don't need to know how to code the presentation. If your students want to do that, if they've done coding in some other classes, they've been exposed to it before, or if they just are, kids can just learn things themselves and figure it out. If they want to do that, you don't have to necessarily learn it, and you definitely don't have to teach it to them. You just allow this as one of the options. I picked 3 that were super cute that had been, used as presentations. So this one's about cyclones. Hopefully it will start up for us. This one's a little hard to understand. I'm just going to play a few minutes of it because it was so adorable. When it loads, if it does load, if it doesn't load, we'll move on. But it's where students are conveying the information that we would want them to convey. They're proving their learning, but they're doing it through a much more, for them, rewarding way, where they're talking about cyclones and what happens. Oh my gosh, it's so cute. And I have a couple of other examples here. There's one about the Mars rover landing, and there's one that's more of a book report about the Diary of Anne Frank. And instead of a traditional book report, they've done it, or slideshow, they've done it as a animated little coding project that they've done. So that's a great way to include programming as an option in what you're doing without getting out of your own comfort zone, if that's not something you're comfortable with. There's so many ways that you can use it. Oops, did I go too far? No. Okay. You can also, if you've got the technology, you can also use lots and lots of other tech tools, right? So codable robots, I use Lego Spike. I've just transitioned over to them. Obviously, these kind of tools are things that you have to, purchase. So you may or may not have resources available, but there's so many ways that you can get them. A lot of times you can get them from your BOCES. You can borrow them. I know Clarkson University has sort of a technology lending. There's different ways that you can get them, I'm sure, in your area. Or if it's something that you can get your school to invest in, that's great. And you may have them. So if you've got coding robots, if you've got little microcontrollers, if you've got Raspberry Pis, or you've got, I love microbits, depending on your developmental area. Yes, I will be sharing these slides for you, so you'll have them. I have some 3D printers. You may have them in your building or in your district that you can take advantage of that technology. You can wrap those things around whatever you're doing. One project I've done a lot is joined with the history teacher. They do the Civil War in 7th grade. And so their 3D printing project is to design a Civil War artifact. And they design it in Tinkercad, and then we 3D print it. And it's something that they can then present to their classes, what their Civil War artifact was. So we tie that in. So we're using that technology, but we're tying it into other content areas. So we're hitting those standards without, while still hitting other standards in other content areas. We do a biomimicry unit where we use our robots and cover echolocation and biomimicry at the same time, and use robots to do that, which is just a very fun way to tie in some science into what we're doing, and collaborate with our science department for that. We do a big unit on bias, and it's an artificial intelligence unit, but it's really much more about bias and the problem with artificial intelligence. And I've tagged a couple of really valuable tools that you can use for that. So Scratch Lab has a facial recognition program. You can spend a day or two with students designing their program to do different things. Like when it sees your nose, it'll do something. When it sees something about your face, it'll do different things. And Teachable Machine is another one where you train an artificial intelligence system to know what a dog or a cat is based on the data you give it. And then you can let students create other artificial intelligence machines where it can identify things based on the data you give it. And it gives you a great opportunity to talk about bias in your data, and how if I don't give my artificial intelligence system good data, it is going to misidentify things because it didn't have good data, and how we do that all the time. The Coded Bias documentary, it's a 2-hour documentary I have used with younger students. I've just used clips. I've picked out sections to have them show. With older students, it is worth a view. And it talks about the bias that is in a lot of our artificial intelligence, especially racial bias, just as a result of implicit biases that are in systems where the users, the developers did not build in their own biases, implicit or explicit, come through the artificial intelligence. So I have a couple examples of some where we did renewable energy sources projects. We're doing some 3D printing. I love sharing the pictures of the students. So if you have those resources and you can use robots in your courses, that's great if you can use those tools. If you can't, there's still plenty of other options that are unplugged, and those are still out there. Now, if you're one of the people that needs to create a brand new dedicated computer science course, I've got 2 examples. Now, there are a plethora of tools out there that you can use. So the goals that you have to decide first are, am I doing an intro? Am I getting up there to computer science applications? Am I getting into the hardcore? You'll determine what it is that you need to do. And the list of courses that New York State recognizes are there with their BEDS code, in case you're interested in that. There are so many free tools. I can't obviously hit them all, but code.org, which is the Hour of Code people, they have 3 different courses that are just beautifully designed. So computer fundamentals, it's elementary. It's got 6, 10 to 25-hour courses, and it's all using block coding. They've got videos that go with things. They've got just expansive lessons and unplugged activities. There's links to that there. Here's an example of one of the coding challenges. It's all block codings. It's fun. They pick it up really fast, especially if they've done like an hour of code. They're going to jump right into it. Middle school and high school can do computer science discoveries. It's 150 up to 150 hours of coursework. They're doing HTML app design in that. And there's unplugged lessons. So like there was a big section on spaghetti bridge as a choice to do. So even if you weren't using the actual coding, we did a big spaghetti. I do it every year, a big spaghetti bridge project, which can tie in so many of those standards. And here's an example of some of the app design that they're using. Computer science principles, even more, and it's Java coding. So it's more for your high school. And CMU, Carnegie Mellon University, has a free computer science academy. So they have Computer Science Zero, which is for middle school. This is all Python coding. So if you were like, we are getting hardcore, I want my kids to code in text. 30 to 35 hours in this first level course. So they're doing very simple Python commands, and they're using a graphics interface. So it's all drawing and animating, which is very fun for them. The second level, Computer Science 1, it's middle school and can be high school. It is 30 to 35 hours. And you're getting to some more advanced graphical design that you're doing with your Python code. And finally, your CMU Academy, that should have said, let me back up there. That should say Computer Science 2. Sorry about that. I still have the 0 on there. It's for your high school, and it's more coursework. And as you can see, you're getting into much more data analysis. You are doing a lot of more advanced things. It's a beautiful course. And it's all free. And it's got classroom setups. You can link it to your Google Classroom. You can monitor all your students' progress. It's just set up beautifully for teachers. Both of these are. So that you set up a classroom, you've got all your students in it. So in terms of grading, it's a breeze. And it's got all that you need. So even if you have never coded before, you could start out with a young group and learn as they go. But if you are a programmer already, but maybe you're not a Python person, this will get you right there. I mean, there's no problem. I couple my Python coding course with other ways to code in Python. So the Carnegie Mellon is kind of the skeleton that we use, and we're running through all those things, and it's covering all my standards for me. But then I throw in some microbits, which has a Python coding, also free. You have to buy the microbit, but the coding piece of it is free. So then they can take what they're learning in their coursework and apply it to the Python or to the microbit and make things light up and make things happen. And so it's a little bit more hands-on. They're seeing something physical happen when they code it. The Lego Prime, because we have the Lego Prime kits, they have Python coding on those. So we're also coupling it with being able to build a robot and control your robot instead of with the block code that they've done in the younger grades. They're now writing Python code to do some of those activities that they've done before, but now they're writing Python code to do it. And also, if you have access to Minecraft Education Edition, which I think a lot of schools do, so these things are not free, but they can be coupled with your computer science course to mix it up so that if you have students who don't want to sit and 43 minutes every day just write code, which I love, but if you want to mix it up a little, you can do other things and still be writing Python code just to make it a little bit more palatable. So you can tie it with other things. And these are just some examples. So now I have just hit you with a whole bunch of stuff real fast. The conclusion basically is that you can build STEM activities use the computer science in any content area. And you can cover them even if you're not an expert, even if you're not tech savvy. All those things are attainable. If you are tech savvy and you're designing a whole course, there are so many resources. And I just picked a couple that I was familiar with. But there are so many, it doesn't have to be intimidating. If your school has the budget and you can pay for some fantastic thing, that's great. But there's free things out there that you'll be able to use. Finally, I've thrown in a whole bunch of additional resources, all these different links, and there's tons more. I just picked some of my favorites. And those are all available to you. And does anyone have any questions? I think our session is, probably over. But if you have any other questions, I would love to answer them. And I will get this shared so that you can have the link. I'll make sure that it is available when they publish everything. So you got the link, and my email address is there. So if there's any way that I can help, I would love to be a resource. That's what CSTA is all about, us being resources for each other. So please reach out to me for anything. I can share what I've done, and you can share what you've done, and hopefully we can just advance computer science in our districts in such a beautiful way. Thank you so much, everyone. If you have a question, feel free to drop it in the chat. And apologize again for my technical difficulties. Okay, let me get you that link. Oop. Here we go. That's my non-bit.ly, so sorry about that. But that'll get you there. You're welcome. Thank you so much. Good, good, good. Glad it works. Oh, look, I see everybody getting in it. That's beautiful. I'm so glad. I will tell you, in my district, we had no STEM when I started. This is my 9th year. And they said, well, what do you want to do? And I was in this boat where I don't know. what are we going to do? And it's been a wonderful experience learning as I go. And I have a computer science background. Before I became a teacher, I worked in computer science. So I'm very comfortable with it. For me, it was learning how to apply that to students and figure out what resources were out there and what could I use. So it's been a great experience learning that. But it is one of those things you have to keep on top of. It's one of those fields where it's changing all the time. And new things are coming up all the time. And you're constantly trying new things and seeing how you could apply them. So we never get to just sit back and use resources that we developed 10 years ago. We're constantly keeping things moving. I like using Python because it is a newer programming language. It's pretty easy to learn. And it's being used in the world. But I emphasize to my students, no matter what computer language you learn, once you learn one, it's easier to learn others because the fundamental logic underneath and all the computational thinking that you do, all the algorithms, all the conditionals and loops, and all those things are universal to any programming language. So if you understand how they work and you understand how to write code, then when you go out in the world and get hired and something new has come up that wasn't around when you were a student, you will be able to pick it up. And that experience that you have now, no matter what it is that you learned, whether you were programming in Java or you have a C++ class, you'll be able to apply that to whatever is the next thing. So we don't have to worry about whether we're teaching our students what they're going to get hired to do, because we don't know what's going to be the thing they're going to get hired to do. But if we teach them these concepts, then they're going to be in a good position when they move on. So that's what I emphasize to them. Python's a really nice one, but there's whatever you're comfortable with. I still remember BASIC and thought BASIC was a great thing to learn way back in the day. And I think that's great. Anybody have any questions? I loved BASIC too, Lori. It was great. I still sometimes just go into DOS and will just, run through my directories in DOS just because it's, yeah, Pascal. Remember in the day? Oh, yeah, Pascal was great. And, we had to get on the internet using a modem and all those things. Fortran. Yeah, I had a Fortran class. Did anybody have to take assembler way, way back in the day? We had to take assembler just so you understood. Ugh. Yes. Yeah, I feel like I was trying to rush because I thought I was going to run out of time because of the technical difficulties. I don't remember when the session actually ends now. So we may have time left and I went way too fast. Does anyone want to look at any of the coding? I hated COBOL too. It was too wordy. Fortran was much better. Back when I was in school, it was if you were going to be a businessy type person, you did COBOL, and if you were going to be a math and science person, you did Fortran. That was the rule for some reason. So That was how we had to do it. You teach assembly to your current students? Really? Yeah, no, I wouldn't want to program. Good for you, Eric. I'm impressed. Yeah, you have to have a math aptitude for word trade. I love that you teach assembly to your students. That's great. You did not use punch cards. That's awesome. I never had to use punch cards. I'm as old as you, I'm sure. I just missed that. But yes, that was a long time ago. Yeah, it's hard to imagine that the technology that we were using that was so cutting edge is now, everybody carries much more advanced technology in their phone, and we aren't even aware of it. Yeah. Yeah, that's great. So for those of you who are retired teachers, I love that you're here. I bet you're using it in, like Lori, you're probably using it in your BOCES. You're using this. You're using computer science in our educational system in other ways if you're not in the classroom. And I love that. It's so important for us to find ways to promote computer science and get our students where they really should be. A few people mentioned esports. I am our robotics coach, and we're doing First Lego League. It's a great one. And our school kind of got behind Lego. We had EV3 before, and now we switched to the Spike Prime. And that was great. I'm so glad that we invested in that. I know there's other things too. I'm just very happy that we picked Lego because it's what I'm comfortable with, and it's very reliable. So I do the FLL coaching, which is awesome. Thank you very much, Joe. It was great to see you. Thanks, Eric. Esports was new. I just started it last year, and I am older, so I'm not a gamer. And so it has certainly been a challenge to get that figured out. Oh, you're senior mentor for Worst in Western New York. Where in Western New York are you, Rebecca? Did you already say Wellsville? I thought I saw Wellsville from someone. My husband's family lived in Wellsville. Oh, you're in Buffalo. Okay. No, near Darien Lake. Fantastic. My husband's from Western New York. So I'm always interested in it. And you have a great representation on the pie chart of the people present at the conference. Western New York is just rocking it. Very, very good. That's great. Our FLL is all run out of Clarkson University up here in the North Country, and that's fantastic. But I'd love to be able to do some like cross the state challenges. Our state is big and it's hard to travel very far, but that'd be really fun if we could get more crossing of the state and doing things maybe out of our little regions. I would love to do that. Oh, you do a dance competition with your mind stores. That's a great idea. I got my district convinced that we need to switch to the spikes. And so now I have a plethora of Mindstorms that we're gradually transitioning. So I'm still using them with some of the grade levels, but switching to spikes with the others. And I'm going to have a lot of spikes left over, or a lot of Mindstorms left over. And they are still, some of them are 9 years old and they're still working perfectly. I love them. I don't want to let go of them. You're in the FLL in Utica, Lori. That's right. Yeah, we should partner with Clarkson. That would be great. Oh, a Minecraft song ballet. That sounds great, Rebecca. You need to speak at the next one, and like you all do, and share some of the amazing things you've done. How many of you guys are going to Nice Skate? Will we have an opportunity to meet there? I'm looking forward to the New York, cohort being able to hang out a little at at the next CST conference. That was a great thing that we did at the last one. But at NYSGate, it'll be great to get to talk about a lot of things. That would be a great CSTA event. Lori, fantastic. That would be. It would be amazing to do that. We should do that. That's great. My students are always looking for ways. I have a big population of students who've really never been out of the county. And some of them have gone, as far as Watertown, they've gone the next county over. And, I love being able to take them places because they've just never gone anywhere. Oh yeah, I love SUNY Poly. I did FTC 1 year at Utica. And it was a great experience. Usually our high school STEM teacher is doing that, but I helped out 1 year to get that experience. It was great. Anybody else using any 3D printing in their environments? I sometimes run out of ways to apply 3D printing. It's fun to do, but I want to tie it in more to other things. So I'm always looking for ideas there. You have 4 Flash Forges, great. That's fantastic. So what kind of things do you do with them? Nice. So I have heard that is a great idea to do board game pieces. At the science conference, the CSTA conference, I met with the Create a Code person, which had you could take your Tinkercad or whatever 3D design and pull it into Create a Code and then make that a character that you are coding. Or you could go back and forth. You could pull a STL file into Create a Code, or you could take one out. So you do design and drawing for production course. That's great. Yeah, so the Create a Code, I just started using it, but it's a really fun thing to tie into your 3D printing, and I haven't done a unit yet. I'm just playing with it still. So that's something great for people to look at. Check out Create a Code. It's one word, Create a Code. Create I code. I'll put it in here. And it is EdLaw 2D compliant. They were very, very smooth. It was a very smooth and easy thing to get our agreement signed. So Create a Code is something you can jump on with. Yeah, I was thinking that too. Everyone here should be presenters, just sharing their ideas. Some of the greatest, and I enjoy presentations I enjoy lots of presentations, but I definitely love the ones that have resources I can take away and look at. So I was hoping that was what I would be able to provide, is some good resources. The Carnegie Mellon Coding Academy, I can't believe that's free. I have to tell you, I just can't believe it's free. It is so good. And there are so many resources, and it's just, I don't understand how this is free. And it's beautiful. So if you go to Carnegie Mellon Computer Science Academy, it is fabulous and free. And of course, code.org is always fantastic and can be used for so many ages. But the Carnegie Mellon one really gets into the hardcore coding. And yeah. Oh, you have 3D print clamps to hold your Lego boxes shut. That's great. Joe, I love that idea. Have an unconference type of session at these summits for grade bands. It's a great idea, where we're just sharing lots of ideas. Everyone could come with some ideas to share if they had some, and then do a round robin. Everybody's getting a turn of sharing resources and ideas. I love that. And specifically, grade bands are important. It's being in the middle school, I can usually pull from elementary ideas and pull from high school ideas and adapt. But if you're dealing with second graders and someone else in your session is dealing with seniors, there's really not a lot you can share with each other. So yeah, I think that's a great idea to share with Tom, Eric. Yeah. Because it is really important to provide all these different ideas to each other and what someone's learned that I haven't heard of yet. I'd love to hear that. Yeah, I love that. Yeah. Make it an actual, session that is networking in your grade band and advertise the idea that bring ideas to share and actually plan ahead of time. Like if you've got some software, some tool, some idea, some unit, some project that you do, to share that with the team. Love it.